What is deep learning? Have you ever wondered how your phone gallery groups all the images and videos based on their location in just a matter of seconds? Or how a ton of data is processed in almost no time? If yes, then the secret behind it all is a product of deep learning. But what exactly is deep learning? Deep learning is a subset of machine learning, which is in turn is a subset of artificial intelligence, which is a bigger concept in all three. But before diving deep into the deep learning process and its aspects, let us first take a look at what is artificial intelligence, what is machine learning, what are the limitations of machine learning, what gave rise to deep learning, what is deep learning, what are the applications of deep learning, what are the disadvantages of deep learning. Let's begin with artificial intelligence. Before learning what artificial intelligence is, it is more important to understand why we need artificial intelligence. Let's look at a real life example. Nowadays, the moment you break a traffic route or exceed the speed limit, you get a notification on your mobile phone stating the offense and the fine amount. What do you think? How does it work? Surely, it isn't humanly possible to make note of every traffic offense when there are hundreds of cars passing by. Is it even possible to do so where there are millions of cars passing every minute? To solve this problem, there are cameras installed everywhere to capture the number of plates of vehicles exceeding the recommended speed limit. The data is then converted into a text format. This example ties up the concept of artificial intelligence. Apart from this one example, there are multiple areas where this concept is applied. Do you know, few people at MIT uses artificial intelligence to predict the future. We are not making this up, and that should give you an understanding of the power of artificial intelligence. Now, let us move forward and understand artificial intelligence by its definition. Artificial intelligence is a technique that simulates human intelligence in the machine and enables the machine to mimic or imitate human actions and behavior. To keep it simple for you guys, our major goal is to have a system and software that can imitate human behavior. Everything that human brains thinks, learns and solve. If you are curious to know how these concepts emerged in the commercial space, do not skip this video and keep on learning with us. To achieve artificial intelligence, there were many technologies introduced, and the first one was machine learning, which we will discuss later in this video. Though machine learning was highly appreciated, there were certain limitations of machine learning that further led to the evolution of deep learning. While the concept of artificial intelligence is not new, it was not given due importance. It was first seen in textbooks in 1856, and years down the line in the 2000s, artificial intelligence and machine learning came to use. The term deep learning was first introduced to the world in 2006, and it brought a revolution. Before understanding deep learning, we first need to look at the machine learning and its limitations. What is machine learning? We all know humans learn from their past experiences and machines follow what human says. But what if we flip the coin and humans train machines to learn from their experiences? For example, if you have detailed data of, let's say, flowers, the machine will recognize what flower it is just by looking and understanding the data. So with the given data, you train your machine to predict a final and reliable outcome. But that's not all. There is a lot that goes into it. We'll discuss that some other day. As today, it is all about deep learning. Let us first understand how deep learning came on board when we already had machine learning. What were the needs or limitations of machine learning that further led to the evolution of deep learning? Limitations of machine learning. High dimensional data. So the number one limitation of machine learning is the high dimensionality of data. Today we have high dimensional data, or let's say data that is generated at a considerable size or number. In such a case, the machine learning model fails, as this technology can't cope with the high dimensionality of the data. Crucial AI problems. Another drawback of machine learning is it is unable to solve the crucial AI problems which include image recognition or natural language processing. Feature extraction. Another major drawback of machine learning models is the feature extraction. In this case, complex problems such as object recognition and handwriting recognition becomes a challenge for machine learning algorithms. Once we have discussed the problem that emerges with machine learning, it won't be fair if I don't tell the solution for these. So let's move forward and understand how deep learning minimized and eliminated these situations. With just a little guidance, the deep learning algorithm can generate features on which the outcome will depend. Also, it effectively solves the limitations of machine learning, such as the dimensionality problem or crucial AI problems. By now, you may have got a good idea of what deep learning is, but to make things crystal clear, let me explain this in more detail. Till now, we have studied artificial intelligence and the subset of it, that is machine learning. Since we already know artificial learning is nothing but to mimic human behavior, in the same way, deep learning is in turn subset of machine learning. The idea is the same, to imitate human behavior. Let us understand what deep learning is. Deep learning is a type of machine learning whose functioning is highly inspired by the human brain. In the context of deep learning, this brain-like structure is known as the artificial neural network. Let us understand in detail how deep learning is better than machine learning and how its disadvantages become the advantage of deep learning. To make things more precise, we decide to create a machine that will tell you the difference between tomato and apple. So let us understand this together. If you are using machine learning, you will explain certain features about both so that it can differentiate between the two. These features can be the size, color, or the type of stem of both the data. However, with deep learning, the process is much easier as the features are easy to pick out by the neural network, like the human brain. Here, there will be lesser human interference and the machine will carry out the task with utmost efficiency. However, this type of independence comes with a large volume of data. Let us understand the neural network in detail. The basic idea behind the neural network is nothing but neurons. Now, you must be wondering if we are referring to the neurons that are related to human brain. Yes, you are right. These neurons are the brain cells that are responsible for transmitting multiple pieces of information between different areas of the brain and the nervous system. Neurons have multiple dendrites that are used to provide input to the neuron. As there are many dendrites, the same number of input will be provided. Once the output is ready, it travels down toward the next neuron. Artificial neural network is similar to neurons. We have multiple inputs that are transferred from various dendrites as in human brain. These inputs are provided to the processing element same as the cell body, and later the summation of input until it generates a function of S. Once it's done, next comes the concept of activation function. Now, what exactly is the activation function? If the output is above the threshold, only then will the neuron fire as it fires in the actual neurons. Otherwise, it won't fire. Once the neuron is fired, it will ultimately check the final output. If by any chance the output is not same as the desired output, we will compare the outcomes and find out the difference between them. Based on that difference, we will update our weights and the process will keep repeating until the final output and the desired output are the same. This process of matching the actual and desired outcome is called the backpropagation method. Now, let's learn what deep networks are. Deep networks are nothing but neural networks with multiple hidden layers. There are numerous hidden nodes in the neural network that are interconnected. After that, there is one more hidden layer node where some function happens and it is further connected to the output layer where the final output is checked if it's equal to the desired output or not. If not, then the process is repeated by changing the weights. Where is the concept of deep learning applied? Number 1, customer support services. While engaging with customer support, have you ever wondered how a bot handles the conversation so well? This is because the conversion seems so real that the customer don't even realize with whom they are talking and continue to go on with their problems. Number 2, medical care. Another area where the neural network is deeply applied is in the medical area, where the neural network detects cancer cells to give detailed and confirmed result of MRI. Number 3, self-driving cars. Before the 2000s, have you ever thought there would be anything like self-driving cars? Well, it is a gift of the neural network to humans, especially to the ones who cannot drive. It almost seems like a science fiction comes to life. Number 4, automatic language translation. With automatic language translation, we can convert any language, say Spanish to English and Hindi into German in just a few seconds or even less. To be honest, these are just a few examples I have quoted. There are several examples of deep learning that we use in everyday life and don't even realize. Some of the world's leading companies, including Apple, Tesla, and Nissan, are highly influenced by the concept of deep learning and use it extensively. Though it offers a series of advantages, deep learning also has certain pitfalls that cannot be ignored or overlooked. Let's move forward and discuss the few limitations of deep learning in details. The first and the foremost disadvantages of deep learning is the data. It has been proven that deep learning is the most efficient measure to build unstructured and unorganized data. However, the neural network always requires a huge amount of data to process and work upon. That isn't easy to handle by all devices. Another disadvantage of deep learning is it requires a higher level of training in the neural network. Also, the neural network requires weeks and sometimes even months to train. The time increases with the data and the number of layers in the neural network. So, that is the end of the today's session. If you have any queries related to what we have discussed, you can leave your questions in the chat box below and I will come back with the answers for you. Before leaving, let's quickly have an overview of what we have discussed in today's session. We start with artificial intelligence and why we need it. There are certain things that human beings cannot perform as effectively as machine can with little or no guidance. So that's why we need artificial intelligence in our lives. We also discussed what artificial intelligence is and what are its subsets. I told you, machine learning is a subset of deep learning. In contrast, deep learning is in turn a subset of machine learning that was introduced in 2006 to minimize the various limitations of machine learning. We discussed what exactly machine learning is and why it became the reason for deep learning evolution that eliminates the disadvantages of such a high dimensional data, feature, extractions, etc. We also discussed what deep learning is, the neural network and the various applications of deep learning. I'm sure you must have enjoyed this video and now have a definitive idea of deep learning and its applications. To know more about deep learnings or to explore similar videos, stay tuned and don't forget to subscribe to our channel for timely updates.
You all would have heard the term artificial intelligence at least once in your life. Such is the kind of buzz that artificial intelligence or AI has created. Almost everything in today's world uses AI in some way or the other, be it your daily Netflix recommendations or predicting the stock market prices. With more and more data being generated each day, the need for technologies like AI is now more than ever. Hello guys, my name is Yugendra and in today's video we are going to talk about what AI really is. How does an AI work and how does an artificial neural network work? And lastly, we will implement a simple artificial neural network using Python and some deep learning framework. If you want to know more about AI and its subdomains, there are videos on that as well, for which I will be providing the links in the description box down below. And for more such videos on any new technology, do not forget to hit that like button and it would mean a lot if you could subscribe to our channel. So without wasting any more time, let us jump right into it. So, what really is artificial intelligence? AI is a science of simulating human behavior in machines that are programmed to perform tasks like us humans and mimic their actions. Any machine that exhibits human like traits such as problem solving and learning constitutes AI. Ever wondered about how a Tesla drives by itself from one place to another without the intervention of any humans? This is possible due to AI. Let us now understand how a human brain works. The human brain sends and receives signals throughout the body. Variety of signals control different processes and our brain makes sense of each of them. Some of these messages or signals are stored in the brain, whereas other signals are sent through the body's huge network of nerves to other parts of the body. To do this, the central nervous system or the CNS depends on billions of neurons or cells in our body. So let us now look at what a neuron actually is and how is it relevant to AI. Neurons are considered to be the basic units of the nervous system. Neurons are also responsible for carrying information all over the human body. There are about 86 billion neurons in the human body, thus comprising an incredibly complex network of communication. A neuron consists of three parts: a soma or a cell body, dendrites, and axon. A soma is a part of the neuron that receives all the information. It contains the cell's nucleus. Dendrites help in transmitting information from other neurons to the soma. These are basically called the input part of the neuron. Axon transmits information from the soma to the other cells. This is known as the output part of the cell, normally ends with a number of junctions connecting the input part of the neuron, which is dendrites, to other neurons. So now, how does artificial intelligence work? The main principle of AI is feeding input data, processing it, analyzing it for any patterns or correlations, and then using these patterns to make predictions or future decisions. Therefore, it emphasizes on three human like behaviors: learning, reasoning, and realizing. In the learning stage, the main focus is to acquire data and make rules or algorithms as to how we can turn that data into something useful. In the reasoning stage, after defining a certain number of algorithms in the learning stage, we now have to choose which is the best one for the task. In the realizing stage, the algorithms are trained over and over again with the right data to ensure that they provide accurate predictions and make important decisions. We will now see how a typical artificial neural network is similar to that of a human neural network that makes up a human brain. An artificial neural network or ANN comes under the umbrella term of AI and was coined to imitate the network of neurons in the human brain so that a computer or a machine can learn things and make decisions like us humans. ANNs are typically a form of deep learning models created by regular computers to behave like they are interconnected cells. Now, how does an ANN work? Structure of an artificial neural network consists of a number of nodes which are loosely designed to compute like that of a neuron in the human brain. Typically, neurons are arranged in a series of layers. The input layer, which receives various forms of data, the hidden layer, this is where the computations happen. This layer consists of many units and its main job is to convert the input data into something that can be used by the third layer, which is the output layer. But when compared to that of a biological neural network, we know that the input is taken in from the dendrites and the output through the axon. Let us dive deeper into the constituents of a neuron, a hidden layer, the output layer, and the weights with a simple daily life example. Imagine you're making coffee. The ingredients that you would need to make coffee are milk, coffee powder, water, and sugar. These would constitute the neurons since they make up the initial part of the process. The quantity of each of these ingredients required constitutes the weight associated with the neurons. The final result is achieved by mixing all the ingredients together in a certain way. This can be called the activation function. Moving on to the hidden and the output layers. A hidden layer constitutes the layer or layers between input and the output layer. It is so called because it is hidden from the outside world. It can be said that the main component of an ANN would be the hidden layer, as this is where all the calculation and processing happens, and finally generate a result which is then passed on to the output layer. In our daily life example of making coffee, the function which regulates the whole process of making coffee is heating. The ingredients now represent the hidden layer. In a typical ANN algorithm, the learning process consists of splitting the data at hand into three different sets: the training dataset, the validation dataset, and the testing dataset. The training dataset allows the neural network to understand and differentiate between the weights associated with each input. The validation dataset is used mainly to increase the accuracy or to fine tune the performance of the neural network. It is not mandatory, but to achieve higher performance, it is recommended. A testing dataset is used to determine the accuracy of the neural network. Now, implementing ANN with the help of Keras. We will now be implementing an artificial neural network with the help of a simple deep learning framework called Keras. But before that, let us first understand what Keras is. Keras is a high-level neural networks API or an application programmable interface which is used to train almost any kind of deep learning model. It is written in Python and it is capable of running on TensorFlow, Theano, and Microsoft Cognitive Toolkit, which is commonly called as CNTK. Keras does not handle low-level operations such as manipulating a dataset, which is usually called tensor manipulation. Instead, it is carried out by well-optimized libraries like TensorFlow backend, Theano backend, and CNTK backend, which also serve as a backend engine for Keras. These backend engines are mainly used for faster computation. We will be using TensorFlow in our demo today. A typical Keras workflow looks like this. The first step is defining your network or a model. In this step, we define the different layers we want in our model and the connections between them. There are two types of models that you can define: sequential and the functional model. The second step is compiling the defined model. In this step, it involves converting the code to a form which is suitable for computers to understand. In Keras, we use the model.compile method. We also define the loss function in this step, which will calculate the losses in our model. The optimizer function, which will reduce the loss, and the metrics used for evaluating the accuracy of the model. The third step is fitting the model or the network. After compiling the data, we fit our model, which in turn is used to train the model on the data. The fourth step is evaluating the said model. We need to evaluate the performance of the network on the same dataset. And lastly, making predictions. Finally, we make predictions using our model on new and untrained data. Let us now see the demonstration. We will be implementing a simple linear regression model using Keras. Let us now start the demo. For this demo, I'll be using the Google Colab notebook just because it's easy to use and it's easy to collaborate with. And also you don't have to install any libraries unlike you do them in Anaconda Navigator. So that's the reason I'll be using Google Colab. And for today's video, the dataset I'll be using is a salary dataset which has experience in years and the salary. So these are the labels. And here we can find the experience in years and the respective salary separated by a comma. So this is the comma separated value file or the CSV file that we'll be using as the dataset for today's demo. Here there's 1.1 and the respective salary is around 3,93,430 and there's 1.2 and the respective salary is around 4 lakhs. Just like that, we have the salary till 10.5 years of experience. So here we have 10.5 and the respective salary is around 17 lakhs 18,720 rupees. And keep in mind that the salary over here is in rupees, Indian rupees. So now let us go ahead with importing the dataset from Google Drive. So for that, the syntax is first you need to connect Google Colab with Google Drive. So from google.colab import drive and now drive.mount. So this is to connect the drive and the Google Colab. So drive.mount the path, so that's /content/G drive since it's Google Drive. And now if you execute this, so you get drive already mounted at this particular path. So if you're doing it for the first time, you'll get an authorization URL. So if you click that and then log into your respective Google Drive account, you'll get an authorization code that you'll have to paste it over here. And then if you click enter, you'll get that drive is mounted at this particular path. Since I've already done it, I don't have to do it again. And now let us go ahead with importing the dataset. So that's import. To import a dataset, we use the pandas library. So that's Python and data analysis library. So that's import pandas as PD. Here PD is the alias that we'll be using. And then let us store a dataset in a data frame called df equals pd.read_csv because it is a comma separated value file. And then now the path will be content Google Drive and in that my drive and then it would be salary_data.csv. So that's salary_data.csv. This is the file name that we'll be importing. And now if you execute this, we can see that the data frame consists of this particular data set now. So to show you guys how the data frame will look like, I'll show the first 5 values of the data frame. So that's df.head. It will give you the first 5 values of the data frame. So here we have the experience in years and the salary. So the first 5 values are 1.1 and the salary is 3,93,430 and the fifth value is 1.6 and the salary is 3,77,310. So keep in mind that the index of the data frames always starts from 0. So if there are 5 values in a data frame, the last index would be 4. And now let us store our values in x and y variables. So here, since it's linear regression, x is called the independent variable and y is called the dependent variable because the value of y here the salary depends on the value of X, so that's experience in years. The salary depends on the experience in years, that is what I'm referring to over here. So X would be df of experience in years, so let's copy this, and then Y would be df of salary. And now if you execute this, X and Y will have those values. And now let us go ahead with the implementation of ANN using Keras. So to import Keras or to import a sequential model, we have this particular syntax. So that's from keras.model import the sequential model. So since the sequential model is what we'll be using over here, so we'll import the sequential model. Sequential model is nothing but a step-by-step model. The output of one step will be the input of the other step, and so on. Now if you execute this, it says, okay, so it's keras.models, sorry. So now you can see that this code has been executed. Now let us go ahead with defining a model, defining a Keras model or a sequential model. So let us import Keras now, and then let us import the layers. That's from TensorFlow.Keras, importing the layers. Since we'll be using TensorFlow as the backend, we'll be importing the layers from TensorFlow. So that's from TensorFlow.Keras import layers. And now we'll go ahead with defining our model. So that syntax would be model equals keras.sequential, since it's a sequential model. And then the input parameter would be 32, because the number of neurons in the first step would be 32. So that would be enter, and then layers.dense. So remember that dense is a function to create neural network or neurons. So over here we'll keep it as 32 to be the first hidden layer, will have 32 units or 32 neurons, and the activation function to be ReLU or rectified linear unit as it's commonly called. Activation is ReLU. So ReLU, what it does is, if the input is positive, it will output the input directly. So that's if say input is 4 or 5, that will be the output. And if the input is negative or 0, it will take it as 0 itself. That is what ReLU does. This is to stop plotting negative values onto the graph or onto the plot. And then input shape would be 1, since the number of inputs that we'll be giving is 1. Over here the number of input we'll be using is experience in years, so that's just 1. So that will be input shape underscore shape equals 1. So this is our first layer or the first hidden layer, and then we'll have two more of this, layers.dense comma layers. So let's close this function over here, and this is useless. Layers.dense 32 itself, and now we don't have to give any input, so just the activation is enough. Activation is ReLU. So that's done again, and now let us give another layer with the same specs. So here we have 3 hidden layers of 32 neurons each, and the activation is ReLU again. And now so that's done. And the last layer or the output layer will have layers.dense of just 1. Just 1. So this is the output layer. And now if you execute this, okay, seems to be the activation spelling seems to be wrong. So let's remove this. And now if you execute this again, we can see that our model is generated. So if you want to, get the summary of the model, that can be done using the model.summary method. So that's model.summary. If you execute this, we'll have the model name as sequential model. And over here, we have the dense layers. So here you have 3 hidden layers. So that's 32, 32, and 32. and the output layer is the last dense layer, so that's 1. And this is how the summary of the model is. And here also you have that the total parameters are 2209 and the trainable parameters is also 2209. This is, they both should be equal. Now let us move ahead with the optimizer function and the compilation of the model. So to do that, we'll have to import the TensorFlow library. So that's import TensorFlow as TF. So TF here is the alias. And now we'll have to use the tf.keras dot the optimizers. In the optimizers, we'll be using the RMS prop optimizer. So that's RMS prop. So RMS prop is nothing but a root mean square prop method, and over here the default parameters are given by them itself, and since we'll have to specify our learning rate, we can do that by just giving the value. So that will be 0.001. So the learning rate for this particular linear regression model I'll be using is 0.001. So depending on the learning rate, the model will perform well or maybe it wouldn't. So learning rate is a tuning parameter that determines the step size at each iteration, so while moving towards a minimum loss function. So the learning rate can be as you wish. So if you go ahead with learning rate to be small, it means that the model will perform a better way. If the learning rate is higher, the model would perform faster and the accuracy might go down. So let us execute this now. So here we have the RMS prop. So that's done. And now let us go ahead with compiling our model. That can be done by using the model.compile method that we discussed earlier. So, and over here, let us store this in an optimizer variable. So that's optimizer equals tf.keras.optimizers and execute this again. So model.compile, the loss function over here, we'll take it as mean squared error loss function. So that's mean. This is predefined by Python or by Keras. It is predefined by Keras. So mean squared error underscore error. So what mean squared error is? The value or the square of the y prediction value and the y trained value. So it'll be, I'll show it to you now. So here it's mean squared error value is equals the y prediction minus the y value for that particular prediction. So let's say if you want to predict y for 4 years of experience or 1.5 years of experience, so the actual value is 3,60,000 and the y prediction value might be greater than that or lesser than that. So that is the mean squared error. The square root of that particular difference or the square of that particular difference is the mean squared error. And after that we need to give the optimizer. So that's optimizer equals optimizer. We've already stored that in the variable. And now let us go ahead with executing this statement. So our model is compiled. And now last step or the penultimate step is to fit the model, fit the compiled model. So that is done using the model.fit function. Fit. So we need to fit the x parameters and the y parameters. So that will be x comma y. These are the values that we'll be plotting or the predicting it against, and then the number of iterations or the epochs would be 500. Let's just take it as 500. And now let us execute this. As you can see that the epochs are increasing over here. So the final epoch would be 500, I believe, because we have defined the number of epochs to be 500. So that is done. And now what we can do is we can use the predict function and predict if our model is performing well or not. So that can be done using the model.predict function. Let's say if you want to predict the salary for 4.3, so you should give it in square brackets. So 4.3. So salary for the number of years of experience if it is 4.3. So that can be executed now. As you can see that the salary over here is 36,413. I think that's wrong. So let's increase the number of hidden layers over here. That can be done. Also, since the value is way off the original value, you can increase the learning rate as well. So let's do that now. That can be done by increasing the learning rate. So let us increase the learning rate to be 0.99 and execute this again, compile the model again, and then fit the model again. Let it run for 500 iterations. After that, predict it again. So now let us predict the value. As you can see over here, the value increased from 3,60,000 odd to 75 or 7,55,539. Let us see if this value is closer to our original value. So let us minimize this. So here 4.3 years over here, and here you can see that the 4.3 years of experience he'll earn around 7,70,810. So what our value is, 7,55,539. So it's almost, similar. So that is how the linear regression is being implemented using Keras. So now I'll show you how to plot these. So for that, you'll be using the Seaborn library. So that's import Seaborn as SNS. SNS here is the alias sns.scatterplot. So since we'll be using the scatter plot, the plots will be or dots in the graph. So that will be x equals x. So x equals x, and then y equals y, and the data is the data frame, that's df. And now if you execute this, so we'll have model Seaborn has, okay, the scatter plot spelling seems to be wrong. Let us execute this again, and now we can see that the values have been plotted and the labels have been assigned automatically. So to fit this line, or to fit the linear regression line using Seaborn, that can be done using the regplot function. So that's sns.regplot, sns.regplot, and the parameters will be similar to this. So let's just copy this and then paste it over here. And now the regression plot looks like this. So there's a line which is being fitted along the data points. So this is the best fit line, as you can see. So let's say if for 4.3 the value would be somewhere around here, so that's around 75 or 7,50,000. So that is the implementation of a simple linear regression model using Keras. You can do many such models, like say logistic regression, multiple linear regression, etc. That brings us to the end of this video. I hope you are clear with how an AI and an ANN work. We mainly have looked at the constituents of an ANN. We looked at how we can use deep learning frameworks such as Keras to implement a simple linear regression ANN model. If you guys liked this video, make sure you hit the like button and don't forget to subscribe to our channel. Thank you.